Good evening, everyone. Today we are going to be looking at the dot product and the cube. How do you apply the dot products to find the angle between two lines on a cube? So firstly, if this is a cube, automatically this side will be your L. Let's say the size of this side, let's say this one is L. Automatically, even the other side, which is this one, it will also be L. This one will also be L. This one will also be L, like that, because a cube has got equal sides. So if this is L, this will be L, this will be L, this will be L, this will be L, and this will be L, this will be L, this will be L. So basically each and every side will just be L, like that. Now what distinguishes the cube sides is what component is it. So as you can see, we have the z-axis like that, which is extended like that. We have the x-axis this side. We also have the y-axis like this. So if that's the case, we are going to have how are we going to find? So we know that the x component is associated with I. So every movement in the x direction, so the x direction, this is a cube, meaning to say if this is your x direction, automatically even this one will be your x direction. So these opposite sides are the same. So if this is x, this one will be x. If this is y, it simply means to say even this one will be y, like that. Let me not make it too dirty. So now immediately, so let's say for example you are looking at from A to this point. So this point, if I was to do this point will be, yes, it's L, but what will distinguish this L, it will be called Li. Why Li? Because it is a component in the x. So this is Li. Just in case you haven't watched the other videos, kindly comment so that I can forward it. Then this one, the one, if this is z, the one going up like that is z, then automatically even this one is z. So the z component is associated with L, K, like that. So this one, if from here up to here, we can call it LK, like that. Then finally, if you look at so this one will be your LJ, since it is in the Y. So if this is LK, automatically even this one will be LK because it is also in the Z plane. So even this one, if you extend it like that, this one will also be in the Y plane. So it will be LJ, like that. Likewise, this one will be your I as well. So basically what we are just looking at are, even if they are opposite sides, since this is a cube, the sides are equal. If this is your x component, even this one will be your x component, like that. So now we have established to say as long as you move in the x, it will be your Li. As long as you move in the y, it will be your Lj. As long as you move in the z, it will be Lk. So now we know that these meet at 90 degrees angles. So now what are we going to be doing? So like, let's say for example, we are required to move. So to help us understand, I have redrawn the diagram to look like something like this. So if you see a different color, it means to say it is a different face. So if you see this blue color, this means to say this is another face of the cube. If you see this one, this is another face of the cube. This one is the back view of the cube. So now, let's say you are required to move, let's say that you have your C here. So let's say this point is C. Let's say you're required to move from, let's say you're required to move to AC. So AC, if you are to draw something, it would look like this. Now here, just think of it as there is space. So what way can you use? Meaning to say, in order for you to move from A to C, you can move from AX. So this means that you can move from AX, I'm just using it loosely, to more like show this point. So we are going to move ax plus, let's say from here up to here, we are going to call it. Now since already this one, if this is your y, then this also has to be your y. So we can also call this one as our, let's just say cy. So if you move from this point to this point, like we are just moving from here up to here. So if you move, you were here originally, you move, you come here. After that, you continue your journey to come C. So all we want is, how can you move to go to C? You will have to move from here up to here, then from here up to here. So already our, from here up to here, this one we are going to call it our L. This one we are going to call it our L. Now L, this one from here up to here, it is the X component, so it is going to be named as I. Then from there, we are going to move from this point to point C. This one will be your LJ, like that. Therefore, in order for you to answer your AC, so your AC should be equal to, what is our AX? So our AX is equal to LI, then we have plus our CY. Our CY from here up to here, which is the Y component, it will be named as our LG. This is very, very important for such types of problems. You should know how to navigate around the system. Let's try to move at AD. Let's say you want to move to AD. So you want to move from A to D. So this one will be equal to, so we already know to say, how do you move from A to D? So remember, this is another face. This is another face. So you must be very vigilant and open up your eyes. So how do you move from A to a point C, like that? So we want to move to AD. So you can see this yellow line. Now where D is, it is on the other face. So as you can see, we have this face, the blue face. We have the back view, it is where the red face is. So we have our A here, we have our D there. So how do we move? So this is very simple. For you to move to D, we have drawn the yellow line, but we can't go direct. How do you move to D? It says that you will go from here, then you will say from here I'll go to here. So immediately you cover this distance. This will be named as your LI, like that. Then the next stage is for you to move from this point to this point. So from this point to this point, it will be, if we extend this, this will be your Y. So from this point to this point, you will have to move a distance of L. Since it's in the Y, it will be LJ, like that. Then finally, you are moving from here. All you want is to reach D. So you can now move from here up to D, like that. So this one will be, since it is in the Z, so as you can see, if this is Z going up, even this one will be your Z. So Z is associated with the K, so it will be LK. Now this means that for you to move from A to D, it will be LI plus your LK plus your LJ. Now just because this is not the only way you can go to D. If you want, you can take this alternative route. So you can make this alternative route. Let's say you move from A going to B. A going to B, like that. Then from there, you will move from this point. All you want is more like, all you want is to reach D. So you move from the point you were at A. So in order for you to find AD, you will say you were at A, you have moved up. So as long as you are going up according to this system, it will be your LK, like that. Then from here when you go at B, it will be, so we write our LK plus, you move from here up to here. What you're going to actually get is our L. Then already, as long as you move this side, if this is your Y component, even this one will be your Y. That's the way it is. So this one will be your LJ. So we can add our LJ like that. Then finally, let's say you want to go to D now. So you are at this point, you move from here up to D like that. So you have found your destination, which is your D. Now this component, when you extend it, if this is X, automatically this one will also be X. So we can say plus Li, which can be written in an orderly manner beginning with the X component. It will be Li plus Lj, then plus our Lk. So already, even if you did this, even if you used another route, it will still be the same answer. So let's now attempt the question. So a cube is placed so that the corners of the origin and the three edges are along the X, Y, and Z axes of the coordinate system as shown in figure 2.16. Use vectors to compute the angle between the edges along the Z axis and the diagonals from the origin to the opposite corner. So line AD. So how do you find your line of AD? So to find your line of AD, we are going to have this type of a situation. In order for you to find your line, the angle between the line AB and AD. So they just want the angle between those. So as long as you see that, just think of the dot product. So the dot product, we are going to say that our dot product will be, so they want the angle between AB and our AD like that. So in order to get the angle, we know we are going to use the dot product. We know that our A dot of B should be equal to the magnitude of A times the magnitude of B times the cosine of theta. They want us to find the angle. So this is the formula connecting the dot product and the angle. So now, if we have AB, we can rewrite our dot product as our AB dot AD should be equal to the magnitude of our AB. So we are just replacing this and this times the magnitude of our AD times the cosine of our theta like that. So if that's the case, we are going to say that this should be equal to, so the first thing is we need to find the dot product of this. However, we need to also find what our AB is actually equal to. So let's just do it side by side. So our AB here will be equal to, if you look at your AB, it is purely, so it is from this point. So if you look at your AB, it is from this point to this point, or rather coming down from down to up. So this is your AB. Now this is purely in the Z axis, and we have discussed that as long as it's a cube, all the sides are equal. So meaning to say this side will be your L. Now which component? Z is associated with K like that. So this is our AB. The other one that we need to find, since we want the angle between our AB and AD, we also need to know what our AD is equal to. So we have already found our AD, but we are going to do it again so that there is clarity. So to find our AD, D is here. So how do we move? So we are going to move from here up to here. So from here up to here, this one will be your L. Then you will say this is the X component. It will be your I like that. Then from here, you will move to this point, which will be your L. Then this one will be your J component, since if this is Y, this is Y, and Y is associated with J. So we are going to move from here up to here. So we are going to say it will be Li plus our Lj. Then we have finally plus. We can continue there, but it's on the space. Then we are moving from here until we reach our point D. We are going to get a LK like that. So we are going to get LK K, like that. So these are our components. So we can be able to just uplift this so that we can use them there to find the dot product. So just in case you are watching this video for the first time, I hope you have certain knowledge about the dot product. If not, just comment on the comment section so that you can be helped. So we have these components. So now first let's find our dot product for this problem. So to find the dot product, we can be able to say our a b dot. So we can be able to say our a b dot ad should be equal to, we are going to open brackets, we have our ab is lk, then we have our ad is equal to li, then we have plus our lj, then finally we have plus our lk, like that. So therefore we are going to get our lk times so here how we multiply the dot product is just the same, the ones that have got similar things. So already your a b dot ad should be equal to, your lk times lk will be equal to just l squared, because k times k dot k, if you multiply them like that, it's just equal to a positive 1. So k times k is 1. So this is how come the dot product ab dot ad is giving us l squared. Now the other thing that they want us to find is the magnitudes of the two. So the magnitude of AB, we know that our AB is equal to LK. So to find the magnitude of AB, we know that the magnitude is given by the square root of x squared plus y squared plus the z squared, like that. So if that's the case, we have the z squared. So this AB can also be written as AB should be equal to, we have our 0 I. That's how come it's not showing to say we have the I. It means to say it's 0 plus 0j, then we have plus LK, like that. So we can be able to say our AB should be equal to the square root of our x squared. So we know that our x squared is 0, so squared, plus our y component is 0 squared because k is associated with z. Then we have plus our l squared, like that. So our AB should be equal to, we have the square root of our l squared, like that. So this squared and this one will cancel. So we are going to remain with the value of our magnitude of AB is equal to L. We also find the magnitude of AD. We know that AD is equal to LI plus LJ plus our LK. So what we are going to do is we are going to say that this should be equal to our AD should be the value, which is the magnitude, should be equal to the square root of x squared plus y squared plus z squared. So we are going to get a square root of our, what is our x squared? So we know that x squared is equal to our L. Our x value is L. So we can say L squared plus our y value, which is the one having j, is also L squared plus our z, which is our L as well. So remember, these are just showing you the position, so we don't include them when calculating the magnitude. So if you add your L squared plus L squared plus L squared, it will be 3L squared, like that. So this will be the absolute value or the magnitude of AD. So the magnitude of AD should be equal to, we are going to say, according to radicals, we can distribute this. So we have the cube root of 3 times the square root of 3 times the square root of L squared, like that. So this one, the square root of 3, we can just leave it like that, square root of 3. This one and this one will cancel. So that's how come we are going to have an L there. So this is our AD, which should be equal to the square root of 3L. So we have found our AB to be equal to L, the size of AB. Then we have found our AD to be equal to square root of 3L. Then our dot product, which is our AB dot AD, is giving us we got L squared. So after doing this, we can now be able to substitute. So we can be able to say AB dot AD should be equal to, we know that the formula is magnitude of AB times the magnitude of AD times the cosine of theta. So our dot product is equal to L squared, which should be equal to our AB, which should be equal to L, times our AD, which is equal to the square root of 3. We are just replacing L. Then we have cosine of theta. The next stage is L squared should be equal to our L times L will be equal to L squared. Then we have the square root of 3. Then we have the cosine of theta. So we are going to divide over our L squared over our L squared. This one will give us a value of L divided by L squared. It will be equal to 1 over the square root of 3, which should be equal to the cosine of theta, like that. So this one, when we do this, we can now find the angle by just saying cos inverse. So it will be cos inverse of 1 over the square root of 3, which should be equal to theta. So our theta value for this one will be our cos inverse of 1 divided by the square root of 3, like that. So after doing that, we can be able to say our theta, what it is giving us, is equal to 54.74 degrees. Yeah, so let's look at the last part. We have found the angle for the first part. B is also asking us to find the angle. So the angle between your AC and the line AD. So if that's the case, so the line between AC and our AD, so we are going to use the same approach. So let's identify. So just as you can see, AC and AD are on different faces. So how do we go about that? Let's identify what our AC is equal to. So AC is equal to, we can move, in order for us to get to AC, we can move from, let's say from here up to here. So this one is in the Y, so this one will be the length of L. Then we are going to call it a J, like that. Then from there we can move from this point going to our C there, which will just be our L. Then going up is associated with a Z component, so it will be LK. So already our AC will be equal to, we have our LJ, then we have plus our LK. Then we know that our AD, but we are just going to retract it so that we are able to understand. So our LK should be equal to, so we have our AD should be equal to, from here up to here, it is a length of L. We are going to call it L. Then since it's I, since it's X, it will be Li. So we are going to say Li plus, from here up to this point now. So this, if this is Y, automatically this will also be Y. So this one will be your LJ, like that. So Li, LJ there. Then finally, we are going to add this one. Then finally, from this point to D, it will be something like this. So this will be your, from there it will be your LJ, like that. Sorry, L. Okay, since if this is Z, if this line is C, automatically all the lines going up will be Z. So we are going to say plus L, then Z is associated with the okay. So therefore, let's first find the dot product. So AC dot of AD, we know that the formula is equal to the magnitude of AD, times the magnitude of even if we interchange them, it's still okay. The magnitude of AC times the magnitude of AD times the cosine of the angle between them. So we are going to say our AC dot AD should be equal to, our AC, according to what we have, it is equal to LJ plus our LK. Then we have our AD is equal to LI plus our LJ plus our LK, like that. So this one should be equal to, we multiply, so we only multiply with the j's. So we are going to have our lj times lj. This one will be equal to L times L, it will be L squared. Then the other part, we are going to have our LK, let it multiply with the K only. So we have plus L times L is L squared. So we have L squared. K times K is 1. So in case you don't know that, kindly comment so that I can forward you the link. So we have our, when we add this, we are going to get L squared plus L squared. We are going to get 2L squared, like that. So when we get the dot product, let's find now the magnitude. So we know that our AC is equal to LJ plus our LK. So to find the magnitude, we are going to say AC should be equal to the square root of our x squared plus the y squared plus the z squared, like that. So when we do that, we are going to get our AC should be equal to, we have the square root of our x squared. So our x squared is 0 squared plus our y squared is equal to L. So we just get the letter L squared plus our z squared is equal to also L squared. So this should be equal to the square root of L squared plus L squared. It will be 2L squared, like that. So already we can distribute this by saying this is the same as square root of 2 times the square root of L squared, like that. So this one will give us the square root of our 2. Then this squared and this one will cancel. So we have this. So this is the magnitude of our AC, like that. So we have found our magnitude of AC. Let's find our AD. AD, we know that it is equal to LI plus LJ plus our LK, like that. So the magnitude of our AD will be equal to the square root of x squared plus y squared plus the z squared, like that. So our AD will be equal to the square root of what is our L. So we have L squared plus our y is equal to L squared plus L squared, like that. So this one, when we add it, we have L squared plus L squared plus L squared. We have our 3L squared. Then when you find the square root of 3, it will be, we can distribute this by saying square root of 3 times the square root of our L squared. So this one will be equal to the square root of 3, then we have L. So this will be our AD, like that. So if we find we know that our AC, the magnitude of AC should be equal to the square root of 2L. The magnitude of AD is equal to the square root of 3L. So now we know the dot product AC dot AD gave us, so the dot product gave us a 2L squared, like that. So we can now be able to find the angle. So we can be able to say AC dot AD should be equal to the magnitude of AC times the magnitude of AD times the cosine of theta. All we are interested in is finding the angle. So now our AC, we know that the dot product is equal to 2L squared, which is this one. So where there is AC dot AD, we put this should be equal to, what is our AC? Our AC, we are going to have the square root of our 2L, like that, times our AD, which is giving us the square root of 3L. Then we have the cosine of theta. So the way radicals are, so first we have a 2L squared should be equal to, the way radicals are, this is the same as having these that are in the square root, they can combine to say 1 square root 2 times 3. If you don't know the radicals, you can just comment so that I can forward you the video. So we have L times L. So also we have these that are outside can also multiply. So we have L times L. Then we have the cosine of theta. So we are going to get a 2L squared should be equal to, we have the square root of, what is our 2 times 3? It will give us 6. L times L, it will give us L squared cosine of theta, like that. So we divide over L squared over L squared. So this will give us a value of this goes. So we are remaining with 2 should be equal to the square root of 6 cosine of theta, like that. So we divide this by the square root of 6. We divide this by the square root of 6. This will give us a value of a 2 over the square root of 6, which should be equal to the cos of theta. We take the cos this side. We are going to get the cos inverse of our 2 over the square root of 6, which should be equal to theta. So when we find the angle here, so we have the cos inverse of a 2 divided by the square root of 6. This will be equal to a value that is 35.26 degrees. So this is our angle there. So that is how you deal with a dot product that involves cubes. Thank you very much for watching. Hope you would like, subscribe so that my video can reach a greater audience. See you in the next tutorial.